Hello students, in this video we are going to discuss the velocity time graph. Whenever a body is in the motion, any one of the following graph can be possible. Velocity along y-axis, time along x-axis I am taking. The graph can be either straight line parallel to time axis, or the graph can be straight line passing through origin, or it may be like this, or like this, or like this. Such type of graph we have discussed in the previous video. In this, the slope of this graph gives us or represents acceleration. Mathematically, we can write tan theta is equal to velocity divided by time taken. This one will give us acceleration. In detail, we'll discuss about each and every graph, subgraph. Suppose if the VT graph is like this, that is straight line parallel to time axis. That means at each and every time the velocity of a body is same. That means V is constant. V is constant. Then tan theta is equal to, theta is 0. So tan theta is also 0. That means acceleration is equal to 0. That means the body is moving with uniform velocity, or it is in uniform motion. Suppose if VT graph is a straight line passing through origin, that means when time t is 0, the velocity is 0. As time increases, the velocity also increases linearly. In this case, the angle theta remains constant. So, tan theta is constant. That means acceleration is constant. And we can say this is nothing but uniformly accelerated motion. The body is with uniformly accelerated motion. We have the equations of motion for uniformly accelerated motion. And if velocity time graph is like this, here it is, suppose say an angle theta 1, here is an angle theta 2, here is an angle theta 3. Here theta 3 is smaller than theta 2 and theta 2 is smaller than theta 1. That means theta is decreasing with time. That means tan theta is decreasing with time. slope of this graph is decreasing. That means the body is moving with decreasing in acceleration. A goes on decreasing. But be clear, it is not in retardation. It is not in retardation. Retardation is different. Here the body is moving with acceleration only, but not with uniform acceleration. It is moving with a decreasing acceleration. Velocity is increasing. Acceleration is decreasing, but not uniform. If the velocity time graph is like this, at different places the theta value is different. In this case, theta 3 is more than theta 2. It is more than theta 1. That means tan theta is increasing with time. If tan theta is increasing, acceleration goes on increasing. A is increasing. It is non-uniform acceleration, 3 and 4. If the graph is, velocity time graph is like this, here theta value is more than 90 degrees, therefore the slope of this one will be negative. So acceleration is negative. Now here actually the acceleration is constant but negative. We can call it is in retardation. The body is in retardation. Here the slope of velocity time graph is giving us acceleration. At the same time, what about area? Area of VT graph. If it is regular in shape, we can use the area of that particular regular shape. If it is not like this, we can use integration also. Integral of V dt. This will give us displacement, and the displacement is also nothing but change in position. Thank you. These are the few different types of velocity versus time graph.